We're live. I never check, so if things go wrong, that's fine. I have a recording and we can figure it out afterwards. But anyways, I
Yeah.
guess to start off, this is another developer workshop. I'm really excited today, bringing on a good friend from Axelar. He presented, I guess, he's bringing on a full code walkthrough, which is really exciting. I'm super, I guess, happy to learn. But I'm going to stop talking because I'm not important here. This lovely individual is, so please introduce yourself.
All right. Thank you so much. Hi, everyone. My name is Idris Olubisi. I'm a software engineer and a technical writer, currently working as a developer advocate at Axelar. And I'm really, really excited to be here to talk about things and also how to build a full stack interchain DApp, and also, of course, deploying on Linea and then doing cross-chain messages with Axelar.
Yeah. Awesome, awesome. So I guess the first question I'm going to dive into, and I feel like you probably have slides for this, is what is Axelar? How does it work?
Yeah,
Right.
so yeah, just to summarize, I'll be going through that. I'll be going through that during the presentation, right? What is Axelar, and then Axelar tech stack, and how Axelar is solving the interoperability between chains, right? So basically, Axelar is a cross-chain communication protocol built on the Cosmos Tendermint SDK, and it helps facilitate cross-chain communication between chains. So either within the EVM ecosystem or from the EVM ecosystem to the Cosmos ecosystem. And I'll be sharing like use cases, how everything started, and then why Axelar and some of the things that the tech stack, the Axelar tech stack, and the GMP messages, which is a feature from Axelar that help you to move, send messages cross-chain, and how to do that with a single click as a developer and also from the user perspective.
Very cool. Yes, I'm excited. We did a panel in what city was it? Paris together?
Paris? Yeah,
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 so many
Paris.
hot takes. That was really fun. I might ask you to repeat everything you said because it was really interesting. Um,
Yeah.
Guys, there's a lot of expertise and knowledge we have here with us today. Okay, cool.
Exactly.
I don't know if you want to dive into it.
All right. Okay, yeah, I'm sharing my screen already. So let me just present and then we get started. Okay. So I still hope you can see my screen anyways. So hi everyone, welcome again. Thank you all for joining. Today we'll be talking about building a full stack interchain DApp on Linea with Axelar. And I will try my best to make you an expert building a cross-chain application through this presentation, and also doing an hands-on coding session where we'd see how to implement all of these things we talk about, from the smart contract to deploying the smart contract, and then connecting it to a front-end Next.js app and testing out the application. So my name is Idris Olubisi. I'm a software engineer and a technical writer, currently working as a developer advocate at Axelar. And also you can find me on all social media platforms as Olanetsoft. All right, so today we'll be going through how everything started with Web3, and in the Web3 space, what happened initially, and then gradually how things evolve over time. And then I'll also be talking more, I'll also be spending more time on Axelar tech stack, what happens behind the scene. And I would also mention how you can send tokens cross-chain, and also the general message passing and some of the use cases that you could leverage when you're building with Axelar. And then of course the demo, the fun part where we create the magic of building the smart contract, deploying the smart contract, and then testing out the smart contract from our front-end application. So now, how did everything started? In 2009, we have the first cryptocurrency launch, which is Bitcoin, and it was introduced by the anonymous Satoshi Nakamoto. I know everyone, might have heard about that. And then this decentralized blockchain itself utilizes the proof of work consensus mechanism, and we gradually see more and more blockchain spin up. In 2014, Vitalik Buterin proposed Ethereum, which introduces smart contracts and enabling decentralized application on the blockchain. So now you don't just use the blockchain as P2P, but also build your own application as a smart contract and then deploy on the blockchain, which is also a way for providing and enabling decentralized application on the blockchain. And we also see the likes of OX blockchain, we see the likes of Uniswap, and then gradually things moved. Things start to change from the era of 2017 to 2020. We have more and more um, solution, more and more network blockchain come up, layer two solutions, the likes of Polygon, the likes of Avalanche, and some other protocols that is helping to scale the Ethereum ecosystem, which means they already identify things like the transaction throughput, finality, and all of those things, right? A way for you as a developer to build an application and also improving the response time and also transaction throughput generally within your decentralized application. So we also see like the likes of enterprise adoption grew up as major countries explore solution around industries like finance, the healthcare system, and supply chain. And we also see decentralized application finance being built on the blockchain, and of course, exploding smart contracts within the era of 2019 to 2020 gains more visibility and also more traction within the space. So, and then it didn't stop there. We start to see more and more application, more and more protocols trying to solve the problem of scaling, solve the problem of interoperability within the space. So, but ideally, how do we scale or how do we scale when we get to add more and more protocols, right? How do we scale? How do we provide more capabilities and features? How do we make the process seamless for new developers, to get onboarded quickly? Of course, we know users have different needs. They have some would consider privacy, some would consider cost, some would consider security, but every DApp with different use cases means that when there's more dApps, you tend to see more chains. But all of these chains are working in silos. They have like different ecosystem, which is why we need an interoperable technology that would connect all of these systems together. And this is where Axelar comes in, right? Axelar is a decentralized interoperability network that securely connects different blockchain and allowing assets, application, and users on various chains to seamlessly interact. So this solved that major pain point in blockchain adoption. So the fragmentation across different chains, Axelar trustless inter-blockchain communication protocol enables this composability without compromising security or control. So the network is blockchain agnostic rather, and currently connects major chains, and we have over 45 chains connected. And this means that all of these chains could connect and communicate with each other seamlessly. So now let's talk about the Axelar stack. What is happening behind the scene, and then how is Axelar doing this? So this is what the stacks look like. Like I mentioned earlier, Axelar is a proof of stake blockchain itself, built on the Cosmos SDK that enables cross-chain communication between the blockchain. So we securely use Validator to securely process and validate these cross-chain messages that I mentioned by collectively voting on their validity. In this diagram that we have the application layer, where you see the like of the different ecosystem, the Cosmos ecosystem, the Ethereum ecosystem, the Polkadot, the Avalanche, and the likes. This also falls in the category of where you as a developer, you build your decentralized application and your users interact with them. But then it gradually moves on to the Axelar API layer, where Axelar provides API for developers to incorporate cross-chain capabilities with the Axelar SDK, or both SDK on the contract and also the front end. And the layer one gateway shows individual gateway on each ecosystem, right? So gateway on each chain serve as an entry point for cross-chain messages within that ecosystem, right? And then we have the Axelar network. So Axelar validates all of the events happening from the layers to ensure the integrity and security. So this is where validation happens. The consensus, we have consensus agreement, voting to verify on-chain events, and multi-party computation. So in summary, it means that on the source chain, you initialize a message on the source chain, it gets routed, and Axelar sends it to the destination chain after meeting consensus, right? So moving on, I mentioned earlier that we're going to talk about the send token function Axelar provides, right? Number one here is, as I would like to call it, the send token superpowers. First, we have deposit addresses, we have send token, and we also have interchain token. I'll be explaining this in a couple of minutes, right? Where we understand what deposit addresses function can be utilized for and how it works, and also send token and also interchain token, right? The first one on the list here is this deposit address, right? Deposit address is a temporary special address created and monitored by the Axelar layers on behalf of the requester. So what you need to do is to install the Axelar SDK and then initiate the Axelar asset transfer, setting the environment to testnet or mainnet, and then you can declare um, um, generate a deposit address, because this is a temporary special address, but it allows you to embed every information that is required for you to send assets to your destination chain. So here we're passing in the source chain, which is the from chain, we're passing the destination chain, and also the destination address and the assets that you're trying to send. So it means that whenever this address is being generated and any funds get sent to this address, it will be routed to the destination address. So now it's already been configured by default, and then Axelar handles the rest for you. The other one here, which is also part of the token transfer functionality, is send token function. This is in Axelar Gateway EVM contracts that facilitates the token transfer between EVM and Cosmos chains, right? It's as simple as, calling this function within your contract and then passing in the destination name, passing in the destination address, the USDC. In this case, the asset here is USDC, is just an example. So you can pass the asset symbol. You can check out the Axelar docs for all the assets that we support, and the amount that you're trying to send. So calling this function triggers this call between any of the protocol. And then, you already specified the destination chain. So you understand the destination chain. You have the destination address and also the asset symbol and the amount that you want to transfer. The last, but not the least, on the token transfer function is the Axelar Interchain token. So this allows you to send token cross-chain, build your own asset bridges, and then build asset transfer into your interchain decentralized application and many more. So how is this different from the send token and deposit addresses? So this allows you to create a standardized ERC token on multiple chains via the Interchain portal, which I'll be sharing the screenshot in the next slide. And then it also allows you to build a custom token on every chain with a built-in method for sending this token. It allows you to upgrade an existing token. If you have already deployed your token somewhere and you want to make it an interchain token, it allows you to upgrade an existing token by deploying a wrapper on every chain. And it doesn't stop there. It also makes interchain tokens executable alongside GMP, which is General Message Passing. Any of these GMP messages for enhanced functionality. So for GMP messages, I'll be talking about that in a few slides for you to understand what exactly it is and what are the features you can benefit from leveraging the general message passing provided by Axelar. So these are the things that you should understand, and also how this is different from the interchain token. So now this is the interchain token service portal, and this is, you can scan this QR code to redirect you to this portal where you can create a brand new interchain token, register it on your origin chain, and then deploy it remotely across any chain of your choice. And you also have the ability to search for existing token and then make that token an interchain token. So in this screenshot, I selected Polygon, but this is not limited to Polygon. You could select any chain and then search for it by entering the token address, and then make it an interchain token. So now let's talk about the general message passing I mentioned earlier. Send token transfer is one feature, which is part of what we discussed and what Axelar provides. So now the Axelar general message passing rather. So send message, this is what I often refer to as like send messages superpowers, right? And we have two main functions here, the call contract and the call contract with token. I will explain this one after the other, and also be seeing call contract in action in during the demo session on how you can use it, you can implement it in your code base, right? So general message passing, the first option here, which is the call contract, is the Axelar General Message Passing. What it does is to enable developers to build on one chain and then call any function on another chain. And this also opens a way for you to interact or send messages cross-chain. So by calling this function called call contract within your contract and then passing destination chain, the destination address, the contract address, of course, and the payload. So the payload in this case could be your array, a string, an integer, a JSON, whatever you want to encrypt in the payload. And then the under is the execute function, which gets run automatically on the destination chain, takes in the source chain, the source address, and also the payload that was sent from the source chain. So this is how you could create magic sending messages cross chain, leveraging the Axelar call contract, the general message passing, and then the call contract function. The other one is call contracts with token, which also give you the general messaging um, functionality with more ability, with improved ability, right? Not to send only message, but also send messages with token. And here, if you check the argument or the parameters that needed to be passed here, it's similar to call contracts. But if you watch closely, you realize that we have the token symbol here and also the amount. So you're not just sending a message, but you're also adding token and asset to that message that you're sending, right? And then we have the underscore execute token function that runs on the destination chain automatically, which also takes in the source chain, the source address, the payload, and the token symbol that you want to send, and of course, the amount that you want to send. So all of these things makes it easier for you to send messages cross-chain and also attach token to that message that you send cross-chain. So now, demo demo time. So let's try to implement and build a full stack decentralized application. So what are we going to do here? We clone a simple Next.js UI and write the smart contract, deploy the smart contract on Linea, and then wire or connect like the smart contract to the front end that we cloned earlier, and then test the application. So after deploying on Linea, by testing the application, we test the application by sending message from Linea to Optimism. So you see how all of these things work. If you want to follow along, you can just use the bit.ly link, Linea Workshop with Axelar, to redirect you to the repository where you can see this the project clone. And not just that, on the README, you find a step-by-step guide on how you can you clone the project, what is required for you to install, and also step-by-step guide for you to write the smart contracts, deploy the smart contracts, create environment variables, connect your front-end application. So now let's get right into it. Just a second. Okay, sorry. All right, so I will be sharing my screen now. So what we want to do right here is to first clone the project from the project repository. So I've already cloned the project here, which you can see on my terminal. This is Linea Interchain Workshop with Axelar.
Can
So
you
we
zoom
will
in a bit
definitely,
so you can make it
okay,
a lot bigger? Yeah,
okay, thank you.
perfect. Yes.
Okay, all right, all good now.
Yeah.
Thank you. All right. So now we clone the project like I mentioned earlier, which I already did here. So what is just required for us is after cloning the project, we do npm install, and then it would install all of the dependencies in the project. And I already installed it. I just wanted you guys to see it. But let's see, after installation, we run the project locally. All right, good, clear. So now we can run using npm run dev. So what is this is going to do is to spin up this application for us, a Next.js application on our browser, which is available on port 3001. Yeah, so we can access that in our browser saying, um, 1 second, it's loading. All right. Okay, so we have, this is what it should look like. Let me just disconnect to be sure we have like the same experience. So this is what you see by default. You see this UI and also an input field for you to enter your message. I want to send cross chain. And then you also see this button and waiting for response. So this is literally expecting a message after we've successfully deployed and then interact with our smart contracts. This message will be retrieved on the front end. So we see what we send on the destination chain, right? So for Connect Wallet, the project you clone already installed and implemented the Rainbow Kit installation. So you don't need to do anything extra. What you just need to do is to connect your wallet when it's time for you to write to the smart contract. So we have this implemented already using WAGMI. WAGMI is a collection of React hooks that makes it easier for you to interact with Ethereum. So as a front-end developer, this is also very useful for you to learn how to integrate all of these together. So now moving on, we have this settled already, and this is what the project repository looks like, right? So now we have this here. But if you remember, our agenda is to write a smart contract. So after cloning the project, what we need to do is to write the smart contract. But before we write the smart contract, what we need to do first is to create a project here. Going back to this place and say, just give me a second. That's not okay. What's going on? Oh, all right. Sorry. Let me just navigate to the project repository and then hit there. All right, so we are here in the same repository, so we can clear this. And then what we're going to do right now is to create a new folder called Truffle. So we'll be using Truffle here to as a tool for us to write, build, and deploy our smart contract. So I can just make it right. So this is up to you, right? You can call this backend, you can call this smart contract, this project, this directly name is really up to you, right? So once we create it, you make sure you seed it into the directory. And then now we are inside the directory. So what we need to do now is to install Truffle globally if you don't have it. So one thing you need to understand here is that Truffle is a suite that is available for you to build, deploy, and compile your smart contracts. If you're already familiar with AdHat, you can proceed to use AdHat. It's pretty much the same experience, but of course, different command line, but you still have the same experience to build and deploy your smart contract. So I already installed Truffle globally, but this is what you need to do to install it globally, saying npm install underscore g, then Truffle. And then since I already have that installed, you can just proceed to initialize a new project. So by saying Truffle in it, and then what this would do is to spin off the project inside the Truffle directory that you just created. So now you can also do npm test, right? Just to be sure, oh, sorry, Truffle test, just to be sure everything is fine and yeah, no errors during the installation. And so I'm trying to test it now, run the command Truffle test and said 0%, nothing fails, right? We don't actually have anything there, but yeah, let's proceed. All right, so I'll be going to the project directory now. If you check the project directory, we have the Truffle folder created, which includes the contract folder, the migration folder, the test folder, and also the Truffle config. This is very important. We'll be spending some time here to configure when we want to deploy on Linea, because we set up an RPC that will help us achieve this, right? So inside the contract folder, which is where we're starting with, you can create a new file. Of course, we want to write a smart contract, so I'll call this send message. So the name here is up to you, right? If you want to name it anything, like maybe custom messages or anything, it's left to you. In my own case, I'll be, I name this file send message dot solve, right? Just to keep the name simple. So what we want to do right now is for us to write this smart contract. First, we need to bring in a Solidity version, and here we'll be using anything greater than 0.8. And then we need to import all the Axelar executables that is required for us to write, compile, and build the smart contracts here. So we have a couple of them: the Axelar executable, the Axelar gateway, the Axelar gas service, and also the ERC20 token that we are importing, right? So, so now defining the contract, it's as simple as saying contract contract, then you can forward this send message. So the name is also up to you to define what you think would be best for you if you want to create the same thing or you're following along during this tutorial. So yeah, Axelar executables, right? Which is what we imported just now. And then you open and close the bracket. So we need to add a couple of things, but to start with, oh no, don't mind, don't mind Copilot. So to start with, right, we'll define 3 variables, and I would explain why we need them in a minute.
Could you
So
also
here,
make this a little bigger? And I think you spelled Axelar executable incorrectly.
okay. Oh, thanks for catching that. Before it
Yeah.
runs into an error during compilation. Yeah. Okay. All right. Okay. Sorry. Okay. Oh, yeah. So is it clear right now? Is it clear?
Yes, it's clear. And then
Okay.
I think you
Okay,
spelled
cool.
Axelar with an E instead of an A,
Exactly, yeah.
right? Yeah.
Trying
Okay,
to
cool.
change it, but I don't know.
Is it not letting you type?
I don't know what's happening.
That's so weird.
Yeah, but I'm not sure. But yeah, let's see. 1 sec. All right. Hopefully it's back. Okay. Okay, I think it's still trying to zoom in and it has messed up with my whole formatting, but yeah, it's fine. So don't mind this underscore. I think this happens when you coding on your Visual Studio Code, you're writing Solidity, you just highlight it for some weird reasons. And then doesn't mean that like you have an error or something. So what we're doing to do next is to create an Axelar gas service, because of course we want to send cross-chain message between source and destination chain. Yeah, so you need to pay for gas, but we are doing it once. So there's already a service that you could leverage, which is the Axelar gas service that help you pay that gas once with your native chain, and then you can, proceed to do your cross-chain interactions, right? I'm not sure why this color highlights is like this, but wait, let me just close this file and try to open it. Okay, now something strange is happening. All right, so um, okay, now, so we created a constructor, right? And also passing the gateway and the gas receiver here. And then what we need to do next is to create a function that actually does the sending of the message, right? This function will take in the destination chain, the destination address, and the value we are sending. So all of these things are dynamic. You need to pass them in. And this will be really useful for us. You'll see all of these things in action when we're trying to send things from the front end. So what we're doing here basically is to create a function here called send message, and then we pass in the destination chain, like I mentioned earlier, and the destination address, the value that we're sending, and we require you to ensure that gas payment is done for this transaction to get stuck or fail for any reason, right? And then you now need to encode this payload, which is the value that you're sending, and then calling the pay native gas or call contract during this interaction, which is in the address, the destination to the destination address on the gas service. Yeah, this is directly on the gas service to pay gas fee for this particular interaction. And then you call the call contract I mentioned earlier during the presentation that actually does the transfer or sending from the source chain to the destination chain. So we're passing in the destination chain, the destination address, and the payload that we want to send alongside this particular interaction, right? So last but not the least here is to add our execute underscore execute function that I mentioned earlier that runs automatically on the destination chain. So basically what it does is similar since we already have the source chain, we have the source address added and also the payload. And then this decode the payload automatically and assign it to the message variable that we created earlier, which is here. So this message variable, why we're creating it and saving it here is for us to be able to, retrieve it at the end of the day on our front end, because we want to be able to, read the message that was sent from the source chain. And also, if you can see here, we are also setting the source chain and the source address to ensure or just to know where that message is coming from, and to also display it on the front end as part of the statistic or the stats for this interaction to tell you, hey, this is coming from this chain and this is the address, and also this is the assets or the message that gets sent from the source chain, right? And that's it. That's all we need to do here in our smart contracts. Let me just add this formatting here to make this okay. Okay, it's already added. All right, good. So going back to the Solidity file here, yeah, this is all you need to send message cross chain, and also all you need to retrieve those messages based on the state variables that we created earlier on, right? So what we need to do now, since we've already created this, we need to just proceed to deploy our contracts. But first, before deploying, we need to make sure everything works fine by compiling our contract. So you can just head back to the terminal and type in truffle compile. So if you're doing this with add hat, you should be able to also compile this. So let's compile our contract. So you can see the error we have in here. It says, but got a contract here. So this is line 12. Okay. So I think we missed a column here. So which is why we have that strange color coding, right? So which is a good way for you to verify that you have everything intact before you try or attempt to deploy your contract. So now we have it, we can just go back and then run truffle compile. Okay, I'll just clear my terminal in a bit. So it says compile successfully, and just do that once again so we see it clearly. It's compiling, so it says there's nothing to compile and everything is up to date. So there are no errors, and we can proceed to set up our RPC. But first, what we need to do here to set up our RPC is to create a .env file inside. So now let's close this so that you see where we are. So currently under the truffle directory. So what you just need to do is to create a .env file under this directory. .env. Yeah. So now, what do we need to add under this directory is our mnemonic phrase from our wallet, and also the project ID that we can get from the infrared project ID. So how do you get the project ID? You can just go to infrared.io. If you go to infrared.io, you create an account, set up a project, you'll be able to get like an API key, and you get this access to your API key. And of course, you can also see, we can get RPC to all of these keys, right? That is where you could literally get your infrared project ID and also your private key. And it's clear that you should not share this private key with anyone, and make sure the .env file is part of the gitignore file. I already added that if you clone this project and you try to work with it. So I will just do the same right now by adding my env file. Okay. Okay. All right. So I just added mine, which added my private key and also the Infura project ID. So you could get that like I already showed. So now let's proceed. What now we've completed the process of setting up our environment variable. The next is to go inside the truffle.config.js so that we can set up. So if you go inside this truffle.config.js, you find out like a lot of comments just to guide you on how to do it. But yeah, first, what we need to do here is to uncomment a few things that we'll be needing in this guide to set up our RPC, which is the first one here. Would uncomment this to be able to read from the environment variable so that we can get access to our mnemonic and then also the project ID. And then we also uncomment the HZ wallet provider, which will allow us to create a provider to connect our private key, right? So you have this option. If you are deploying locally, you can enable this, the development environment is already set up there. Just on commenting it, you'll be able to run it locally. But since you're not doing it locally, you're deploying on the Linea network, which is a testnet, on testnet, right? So we don't need to enable this, right? If you can see, you see the advanced, you see if you're deploying to Goalie network and all of that. But yeah, in this case, that we are not doing all of this. So let's just set up for linear testnet and also the optimism. So remember I mentioned that we're deploying on linear and then send the cross-chain message to optimism, right? So we need to configure for both of them. So first to start with, we start with linear goalie. Of course, so what we're doing here, we enabling the mnemonic phrase and then linear goalie network. We got this URL from our inferior, then you are adding the project ID. And of course, very important for you to set the network ID, which is 59140 for testnet. And the other one is the optimism RPC setup, which is the network ID is 420. And we can just do the same thing the way we did for linear. And then that's it. That's what we need to do here to set up our RPC. And then to be sure we can deploy our application or we can compile and deploy our smart contract successfully. So next, what are we going to do next? We're going to deploy our smart contract. So now we can navigate to the migrations folder and then create a new file called underscore. So you can call it deploy underscore contract, right? The JS. So now this is our deploy script. So one thing we want to do here, remember we want to deploy to Linea. And inside our contract here, let me just go back there. It's very important you don't skip this step. Remember that in our constructor, we are passing two variables, which is the gateway and the gas receiver. This is Axelar gateway and also gas receiver. So in our contract, we'll make sure that we pass in this particular these two arguments to ensure our contracts get deployed safely and also everything is set correctly. So with that, it's very simple. For linear, sorry, close this so it's clearer. So for linear, this is all you need to do to get like the artifacts from the directory and then the gateway address. So for linear, we have this gateway and then the gas service, we have this. So if you want to get to the gas service, very simple. Just go to the docs.axelar resources under testnet. You can find the what is required for you, the chain name, and for all the chains supported. So for linear, we have the gateway contract. You can just copy this and then go back here and then paste, then go back to the docs and then get for gas service contracts. And that's it. So now we can safely deploy our smart contract to linear with all of this setup. We've compiled our contract earlier. What is required for us now is to deploy this contract. So now go back to the terminal and then type in truffle. So truffle migrate, excuse me, dash dash. So network in this case, because you're deploying to linear, to the linear underscore goalie. This is the name we gave. Let's go back to the truffle config. You can see the name here is linear goalie. That's why I'm mentioning linear goalie here. So now you can deploy. Okay, sorry, so that's maybe it's truffle, not the other way around. All right, so I'm currently deploying now to Linea. I've
Oh, I think
successfully
you
tested.
also spelled network as net rock.
Oh,
Yeah, also if you could zoom in a bit too.
okay, let me just zoom in.
I'm like,
Thank
I
you.
can't tell if that's misspelled.
I'm like, like, what's happening?
Yeah, yeah,
All
yeah.
right, so, um, okay, one sec. Okay, truffle network. Thanks for spotting that. Yeah. So let's see if thing goes well, and then recompiling our contract. Actually, we didn't change anything after the last compilation. So yeah, just go ahead and deploy. So you can see the network name is Linea Goli, and then the block name is this. So you say deployment failed. Okay. Oh, this is strange. All right. Okay. Let's see. Is there anything wrong here? Um, all right. Well, for some reason, it seems everything is fine. Well, I'm not sure. It's currently compiling and trying to redeploy. Oh, said it's an invalid copy code we're trying to deploy. Okay, okay. So this actually satisfy all of these, but we confirm we have everything set up here in the traffic config. One
Yeah. Did you say you
second.
already deployed this before?
Yeah.
Yeah. I wonder if something weird happened. I know Linea's going through some changes right now. Also, Truffle has had some weird things too.
Oh, okay.
I was gonna ask you why you chose to use Truffle, actually, just out of curiosity.
Yeah, yeah. I realized, kind of connection between Infura, Truffle, and yeah.
Yeah,
So,
no, no, that makes sense.
so I just wanted to use like the whole stack.
Yeah, yeah, yeah.
Also, you can use add hats, of course, to do this really fast. But
Yeah.
I've tried this even this morning. I deployed like twice with the same with the same process, following the same
I
process. I'm
don't
not
know,
sure why.
things happen. I'll check the
Yeah. All right. So one thing we can do deploying these is let's try to. Okay, let me just try to deploy to Optimism and see what happens. Let's just be sure. Okay. All right. Almost there. Compiling. Let's see. Um, I'm not sure. Oh, we keep the same reason that there's something wrong.
Hmm.
Just give me a sec. Let me see if we miss out anything. I think this happens mostly with demos. uh, okay, give me a sec. Oops. Click the wrong button, but give me a second. I'll be back. Um, okay, save the contract. All right, it's fine. Yeah, yeah. Okay. So I'm just trying to cross check if I might have missed something out. But yeah, I think I'm pretty sure I did not miss anything. I'll just this, then this. Yeah. Okay, so I'm going to share my screen. Okay, I just confirmed everything well. I'm not sure why deployment is failing. Sure why deployment is failing. Um, it says defeat an invalid pool while trying to deploy, and then um, it is strange, but it does happen. Oh, okay, okay. Just give me a second. I think you should see what might happen. Okay. Wait. Is the compiler? Let me try to. It's not even the compiler. I'm not sure it's the compiler because it sets anything from 8.0. So let's see. All right, so we can actually, if you're using any development tool like Hat, I think you can also follow the same process to deploy. I'm
Does
not
it
sure why.
deploy locally? So if you run like a truffle develop.
Yeah, I don't have the Ganache instance
Oh,
running,
no.
but
So you don't. So there's an instance of Ganache within truffle. So if you run truffle space develop in your terminal.
okay, give me a second. Where, here,
That should run an instance on, I think, 9545. And then you can do a migrate here, just like migrate.
okay.
Oh, can you uncomment development in your config, though?
Did I enable it? Oh my God. Okay.
Okay, so then if you just type migrate. Oh, wait, but you're using existing contracts, right?
Yeah, I'm using existing contracts.
So you'll also need a fork, and you can't fork through truffle, so you would have to download
Yeah, yeah,
Nash.
yeah.
Okay,
So
never mind. This isn't.
yeah, but this works locally. I'm not sure why. I'm able to
Yeah.
deploy
I
this
mean, I
instance.
feel
Yeah,
like it works, but it's like fake addresses, right? So it's not
yeah.
actually interacting with it. But if you had forked Ganache, but
Okay.
you don't have it on your thing, uh, live debugging. This is fun.
Mm, yeah. Just give me a second.
Uh,
The error is pointing to. Let me try and see what the error is. Says. Try. I think I've gotten something similar before, about 3 days ago,
oh,
and then I realized that it was versioning that caused the error, which is why I actually specify to use this. Okay, let me confirm another thing here on some of our packages that was installed. Uh, yeah, yeah, yeah. Okay, let me just try this second. Because I'm pretty sure, like, I'm sure why I'm getting this right now. And I need to update the book compiler and then yeah, yes. Okay. Um, okay, check. Yeah. Um, contract. Oh my God. It's the compiler version. Fixed it. So it's currently deploying. So that's one thing, that's one strange thing happening, right? Woo! Finally, it's deployed on Linea. Yeah, so we have, oh, yeah, cool down. Yeah, so we have it deployed now on Linea testnet. So you can see we have our contract address, and also you can verify these on the Explorer just to be sure like everything is fine. I'll also keep track of it. So this is not the address. So let me paste the new one that we just deployed locally. Yep, enter. So we have it here. So you can see it was deployed successfully 47 seconds ago. So now we good. We good. We good. So we can go back to yeah, we can go back and then okay, yeah, it's very important that we note the contract address that we just deployed to, right? So one thing I usually do is to come back to um, the migrations folder and then under deploy commit. So I can add a comment here saying Linea. Oh, sorry. Okay. Let me go back again and then say thing. So just add comment here, Linea, and we can drop the contract address. Yes, because we'll be needing this for front-end interaction later on, right? And then so now we can deploy to optimism, just pretty much the same process. Nothing have changed. Hopefully we don't face any error again. But it's part of the process anyways. Um, 1 second. Okay. All right. It's also deploying. And yeah, there we go. Successfully deployed to to optimism. So what we can do again is to just note this optimism and then just add this here. So now we successfully build, compile, and deploy our smart contracts. What next? Let's wire up. Let's see something in action. Let's test it on a test net, right? So now we're done with anything inside the truffle environment. That's the truffle folder, right? In your own case, maybe you're working with hard hat, it still works the same way, or you're working with Foundry, it still works the same way, right? For you to build, compile, and deploy your smart contracts. So what we're doing next now, after we done deploying, you need to go back to the root folder and then create .env file, .env, .local. So what we want to add here, we want to add what we just deployed, and then we also want to add an RPC URL for optimism, right? So basically, the RPC URL here, you see that in action on front end when we try to read message um, from optimism. That's what we initially sent, and we try to retrieve it back from the blockchain. So another one here is the linear contract address that we just deployed. So you can just copy it earlier and just go back to where is this? Okay, yeah, cool. Yeah, so I can enter the address here and go back to the deploy content and copy for optimism. And that's it. You set up your local development. So now we can head over to the index.js file because that's where we have like tons of things happening. But before then, I think I almost missed out something. This inferior .io/vc contain the project ID. So this is similar to the project ID you copied from the Inferior dashboard, from your dashboard on Inferior earlier on. So I'll just go ahead and then add mine. So of course it's free. You can create an account. You create an account for free, and then you come back here to utilize the project ID. So now let's go back to our project inside pages folder, then inside index.js. So inside index.js, you see all of these things already set up. Like these are mostly styling, no functionality yet. And also we implemented the React, the switch for making dark mode and light mode, the rainbow kit for collecting your wallet, and also the WAGMI setup and the Axelar JS SDK on the front end, which we'll be using to get our gas estimates, because of course, for every chain, there's different gas utilization. So for you to get the estimate when you're trying to facilitate or send messages cross-chain or sending assets cross-chain, you need to get an estimate. And then when you get that estimate using the SDK, you can just pass that in to do a write functionality into your application. But to start with, so what we're going to do here is to import all of our environment variables that we have created, and also import our contract ABI. So um, let's go ahead to import the contract here. So send message. In our own case, it's called send message contract. And what we're doing is to navigate into the truffle directory inside the build folder under the contract directly, and then pointing it to send message or JSON. And we're also importing the next public linear contract address that we added, and the optimism contract address, and also the optimism URL. So to start with, we are going to do a read functionality where a user can input a message and then click send to write into the Linea blockchain, which would end up get sent by the Axelar um, network to the destination chain, which is our optimism in this case. So to start, we will set a couple of state variables for both messaging and also the gas fee, right? So it's similar to the way you do. It's very simple. You're sending your a new message, state variable, and then the Axelar query API, setting it to testnet, and of course create another variable to get the gas fee, and then setting the gas fee default to 0. The next, what we do is to get this gas estimator. So we want to get the actual gas fee for us to initiate this transaction so that it doesn't fail. And of course, we don't add code a specific fee, since the gas fee varies based on network, right? So keep creating a simple function here that gets like a gas fee, and also pointing it to Linea. It takes in a couple of a couple of parameters. Here you could see like the source chain ID. In our own case here, it's Linea. So you just need to point to it. It's already been provided by the SDK. Just point to it by saying EVM chain Linea, and then the destination chain here is optimism, and then the token symbol is if, of course, and of course, these two fields here are optional, but here you can add it. This is a gas. You can find all the details here actually. So this is the gas limit. In this case, I'm using 7,000, and then the gas multiplier, which help you to buffer the gas times 2, so that just to ensure that the transaction doesn't fail at any point, right? And then you have like a gas enough for you to pay for this transaction fee. So now let's proceed to write function. So this is like very important part, and I would like everyone to, concentrate here when we try to write into our contract address, right? So write on the Linea blockchain rather. So what we're doing here, we're using use prepare contract write hook, and it takes in the Linea contract address, the ABI, which is our send message contract.abi that we imported earlier on. Excuse me. And then the send message function, right? This is what we created earlier on our smart contract. And if you remember that the send message function here, let me just quickly go back to the contract here. It takes in, send message takes in, accept destination chain, destination address, and the value. So going back to the front end, here we are also passing the destination chain, which is optimism. We're passing the optimism contract address that we deployed into, because this is from our environment variable, and also the message that we're sending from our front end. And then now we're passing the gas fee, which is generated or estimated by the gas fee estimator using the Axelar SDK. And then what we're doing here is to write, passing in the config, and wait for the transaction to succeed so that we can keep track of the sources, and then show something very, very nice for user as a feedback to let them know, hey, your message is currently being sent, or hey, your message has been sent successfully, right? So next, what we need to do is to create a very simple function that we'll be calling in our send button. This is very simple. This takes in our rights, that initiate the contract call, which you get from the use contract rights. All of these things here that you're seeing here are ways for you to write to a contract using Wagmi or the Rainbow Kit, right? So now we have the toast information here. This is just showing a toast after you initiate the call to write. It says send messages, sending message, right? And then move. That's all you need to write the message. So next, what we're going to do is to call our gas estimator on and use the effect. So once the component mount, you'll be able to get a start gas estimator and make sure it's ready. So before you send the transaction, you already have an estimate of what the gas looks like. And then here, for us to also to keep track of after the transaction is being sent and it's successful, we want to give user a feedback saying, hey, your message is sent. Or maybe if you run into an error, say, hey, your transaction did not send for some reason, a transaction error. So we can just listen to its success, which is something we already have access to from the WAGMI hook, and it keep track and says message sent after it has been sent successfully if it's success, and then if it fails, it says error sending message, and we can also keep track of the use contract rights data and also use wait for transaction data. So all of these hooks are coming from our WAGMI hook. You can look it up on how to interact with this with contracts from your front-end application. This is how simple it is to interact, right? So now we set up the functionality. Now let's call it in the actual input message. Let's grab the input from the text area. Let's grab whatsoever any user is typing into the input and also call the onClick function. So here we'll do onChange, then we can pass in the set message, the e value to the set message state variable that we created earlier on to update the message variable. So now we can also do the same for send button here, which in this case, it's a button, so it's going to be an on-click handle message. So that's it. That's it. This is literally what we need. So we can safely go back to our application here. And if you want, just to refresh and be sure everything still works, nothing good. Yeah, so now, so I have my Linea connected. So if you want to see that again, right, this happens like by default, but let me just connect it again, which is the experience you see if you clone your project for the first time and you run through this process. So now I can click on MetaMask and it gets connected. So I can enter a message saying, hello world. Hello world, right? Which is the first thing we do most times, that's the programming language, right? So hello world, and then we click send. So it says sending message, which is the notification that we enabled earlier on, the toast notification. And then we click confirm, you can see transaction here, and then we confirm the transaction. We go back to our application and then wait for some few seconds. We should get a feedback after the message is sent. Yes, so it's message sent, right? And of course, in a few seconds, we should get a confirmation from MetaMask indicating our message is being sent successfully. Okay, yeah, I think, is this it? Yeah, should be. All right, so this is it. Message sent successfully. So we can head over to track this movement to see how this moves from one what is happening behind the scene during this process, sending this message. You can go to testnet.axelarscan.io and then enter the transaction hash for that interaction. You can copy it from the MetaMask, and then we just want to see what is happening and also during the process, how it's moving from linear to optimism. So yeah, you can see, right? It gets tracked here. It's sent already and also gas paid successfully, and it's waiting for finality. So here is the thing, right? Cross-chain transaction needs to be finalized on source chain before they can be settled. So this requires Axelar to wait for an approval. And in this case, you can also track the minutes that you need to wait for this to get finalized on the network before it will be approved and then executed on the destination chain. So which is approximately 30 minutes. So yeah, we can't wait for 30 minutes, of course. But for now, I already have like a sample that we can check out to see how this works. Just give me a second. And what I need to do is just quickly update the environment variable here. Just give me a second. Okay, so I'll be updating with this here, contract address, and then this here. Okay, so now saving this and then going back to our application, this is still going on and it says 28 minutes 31 seconds. So keep counting down where you could keep track of what is happening. And then if you come back to this application and then refresh this page, because now I've changed the contract address to an address that already sent this transaction, right? This finality is based, depends on different chain, right? Different chains has their own finality period. And then, so you don't need to wait for 30 minutes for every chain. This is also determined by what is happening within the network, congestion, and all of that. So now I can change to optimism so that we can read the message that we get sent, that was sent earlier, right? So remember that we haven't implemented the read functionality. So let's do that quickly in our code base. So I would just go back to the index.js. We only implemented for write. So now it's time for us to implement, for us to read message from the blockchain. So what do we need to set up to make this happen? First, we need to create a state variable that holds the value that we want to read from the chain, from the blockchain. Here, in this case, from optimism, which is where we sent the message to. So let's just copy that here. And then now we're done with this. Then we can proceed to create a very simple function to read that message for us, right? So we'll also be utilizing the hooks provided here for us to read message. And then you see that in the action shortly. Okay, 1 second. All right, so what we're doing here basically is to create a provider using the ETAs and then connect to the optimism RPC URL we added earlier into our environment variable. And then we pass in the optimism contract address, the send message contract ABI, and also the provider that we created earlier on. And then we created a function, which is called read destination chain variables. Here, we are reading the message on chain, and also we're reading the source chain to be sure where the message, the source chain, that's the message we sent, is coming from. And then we're setting the value here and setting the source chain here. So these are the things that we reuse in our front end to display the message here. So, but then after creating it, let's proceed to call this function when the component mounts, which is read destination chain variables, right? So now we can now update our UI to reflect these changes. So what we need to do here is, here we have the created value earlier on, right here in the state variable. Let me scroll up so that we can see what I'm talking about. Yeah, so we created this value. So I'm calling that value on the UI. I'm checking if it contains the value. It should return the source chain. It should return the network here is optimism. These are just UI changes. It has nothing to do with the contract. And also it should display the message. If not, it should show waiting for response. So when we click save now, because it's updated the contract address earlier on, we should see the changes here. So here we go. So you can see the response says Linea, from Linea, and also to optimism, and then hello from Linea. This is the message we sent from the source chain to the destination chain. Hooray, we have it, we retrieved it. And this is the similar process that you can follow for you to build your own full stack interchain decentralized application. From the contract side, write the contract, compile the contract, and then deploy it, then come to the front end and connect to this contract. So don't worry about like the steps. In the project repository here, we already have like each step for you to take to achieve this all through when you are going through this on your own, so you can follow through to understand. So now let's go back to our presentation. There's one more thing I would like to show us before we end this, which is So, okay, hopefully, I think you can see my screen here.
Yep.
All right. So now, one last thing here we want to do is to talk about the Axelar examples, right? It's very important because you can find tons of examples there, not just for sending messages, but also sending messages with token, using call contracts with token. You can see basic functionalities that you could do, like sending token transfer, sending caution messages using call contracts with token, and all of these things. And additionally, you can find some advanced examples also, like for you to use an NFT linker, for you to use send arc function that allow you to send message and also send back an acknowledgement when the message is received, right, on the destination chain. So there are tons of things that you can play around with using this, and also um, building your own project, thinking through how you can make your project cross-chain project. And yeah, so what next? It's easy to build Interchain native DApp, to be honest, leveraging the Axelar SDK. And we don't just allow you to build and just build, just building alone. We also provide 24/7 support on our Discord server, where you could join the developer channel and post your bug. If you're facing any bug, or you have question, or you need clarity on anything, we're happy to help you. So thank you very much for your time, and you can scan this survey to give me feedback on what you think about the presentation and how the presentation has helped you learn something, and also how the presentation will make you an expert utilizing the Axelar SDK to deploy on Linea and then send a cross-chain message to Optimism. Thank you very much.
Wow, thank you. That was so thorough. I have lots of questions actually. Um,
Okay.
so a few things, right? I think like talking to you, this is around the first time I've heard the word interchain. Can you differentiate that from like cross chain and multi chain for the
Okay.
people out there who don't know the difference?
Yeah, so I think interchain and cross-chain is similar. It's kind of the same thing. It's just we utilize interchain at the Axelar team, right? To position ourselves, kind of, right? But ideally, behind the scene, when you say interchain, is also similar to what cross-chain does. So you're just facilitating cross-chain communications between chains.
Okay, cool. And then when you were talking about the finalization of like I guess settling the information on the source chain, so like Ethereum layer
Yeah.
1, for example. Does that mean for like optimistic chains it's gonna take 7 days? Because that's how long they take to finalize, right?
Um, yes, so I think the finality time is it depends on the block height, right? So this varies from chain to chain, right? But it depends on how, one thing Axela is all about is for us to ensure that um, particular transaction gets settled and finalized on chain before we can proceed to approve the transaction and then send it cross chain. So all of these things depend on the protocol itself and also how they're handling it. So I don't really know what happened behind the scene for optimism stake, right? But yeah, this is my understanding on how the cross chain finality works.
Okay, cool. Yeah, because I was thinking like with optimistic rollups, the thing
Yeah.
that I guess their drawback is like from L2 to L1, at least like withdrawals of like ETH, for example, they have the 7 days for fraud proofs before actually
Yeah.
finalizing. So that's
Oh,
interesting. I mean,
that's
there's like
interesting.
immediate liquidity pools that sometimes they leverage, so that might be how they might get around it with Axelar. I'm not sure. I'd be curious. The
Yeah.
other piece that I think is really interesting, I actually see a lot of examples of like send message with just like strings, right? Can you give
Yeah.
me some examples of like using send message in kind of a more real context to kind of get
Oh,
the
okay.
users flowing?
Oh, yeah. So, send message. This is just an example to introduce what it's all about. But during the presentation, I mentioned like it's a payload, right? You can send a string, you can send integer, you can send array, and also you can send like a JSON. So this all depends on you as a developer, what you want to move from one protocol to the other. So you can all like encrypt all of this as a payload to that particular transaction call. So it depends on you what you want to say. So one very good example here is the call contract with token, right? Where Squid, I don't know if you heard about Squid.
Yeah, yeah,
Yeah,
yeah.
they help with swaps and all of it. So under the hood, they utilize Axelar to do all of this. So you can see this interaction in action and also doing all of these swaps from one asset to the other with a single click, and everything just happens super fast. So that's one use case. We have some other use cases like the one for Junkyard NFT. I don't know. Have you heard about Junkyard NFT?
I'm not familiar with that project. No.
Oh yeah, so I know you have NFTs. You have some NFTs that you don't use, worthless NFTs, right? There are some very still useful. Yeah. So what you do is to get all of those NFT that you don't, they are of no value, and you kind of dump them into Ethereum, and then you fish a valuable one in on Polygon. So that interaction between the Ethereum and Polygon is facilitated by Axelar network. So they allow you to do all of this. So you can dump your, worthless NFT and then get more valuable ones. So that's another
Interesting.
use case for you
Yeah.
to see how what they are actually using under the hood is this crushing messaging that just
Yeah.
demoed right
So I
now,
guess like a
and they were able
lot
to do
of
that.
things people usually pass are like contract addresses around as an example of like, because I guess that's just a string, right?
Yeah, yes. So that's why I said it's a payload, right?
Right. It could be anything.
So anything basically. You're
Yeah.
not restricted to a string. So if you have like a use case for you to decode one thing and then encode one thing on the source chain and then decode it on the destination chain, so you're free to pass it. So the good thing is that with the general message passing, you have the option to send message, which is literally anything, and we have the option to send message and token, right? But
Right.
if you want to do like native transfer, you can still utilize the send token for you to move only assets from one protocol to the other, or make like swaps and the like.
Okay, cool. I'm curious, like, because I've seen you at a few hackathons, if you have like something really interesting that you wanted to highlight. Or
Oh, okay,
a cool
yeah.
project you've seen at a hackathon. Because 'Cause I'm curious, like, Axelar's I feel like cross-chain or, like, really interesting interchain applications are a little bit more complex to build, and I'm curious what
Okay.
people are achieving within, like, 2 days
Yeah,
of
that's,
no sleep.
that's why we exist, right? That's why
Right,
Axela exists. Yeah.
that's why
So we don't want you to go through like the hassle of building, try to reinvent the wheel or think through.
right,
That's why we
yeah,
provide like
absolutely.
SDK for you. So one of the projects I would like, which is like, I think they won a bounty from the recently completed Eat Global Paris. I think they call themselves, I can't really remember the name, but something pay. What they do is they create merchant wallets on Safe, and then you as a user, if you enter any store and you want to pay, what you just need to do is to scan a QR code, right? So of course, this solution exists on one chain. I think we've seen an example of the likes of Binance Pay and some other ones, right? But yeah, what they were doing under the hood is to utilize Axelar to facilitate cross-chain. So even if you are paying, maybe you have asset on Polygon or you have asset on Linea and that's the only thing you have, right? You can just scan it. They will deduct your native currency and then credit the merchant in any currency that he wants or he prefers, right? Because under the hood, they just do they receive the funds with any native that you're paying with anything native to your own currency. So either you are using Polygon, Linea, or you're using any other chain, or you have assets somewhere and you don't have somewhere, you don't need to like be restricted to use one protocol for you to be able to benefit from scanning and paying the QR code, which is like one very good real world use case that also make this process of payment seamless. And even the users does not need to think about, but I'm not using this chain. How do I sign up? How
Right.
do I do this? All they just do is to scan and they pay with their crypto wallet. So, and that's the only thing they know that's happening. But under the hood, Axela facilitates that kind of interaction. to make sure that the merchant gets credited
Yeah.
the amount he or she wants in their wallet,
Okay.
in their wallet
Cool. So
rather.
Axelar is very good for like I think when we talk about DeFi and multi-chain and cross-chain and everything, liquidity fragmentations usually an
Yeah,
issue, but I guess, this kind of solution is what allows us to leverage multiple pools. Um, I am
yeah,
curious though,
exactly.
does this also run into the issue of like that finalization piece, right? Because sending the token would take some time if you're doing it between a bunch of chains.
Yes. The truth is that for a transaction on chain to be considered trustless,
Right. Yeah.
speed is, you don't need to worry about speed, right?
Right.
If you really want to get like it. But another thing we provide is what we call the express token transfer.
Mm.
This is based off request, right? So if you want to speed up the process, we can allow that to happen. And then, but there are always things to like check and balance to see why the need of doing aspects and also why not just wait
Mhm.
for this to happen,
Right.
right? And also, yeah, so different protocols are also thinking on how to scale and make their finalization really fast. So I think over time, that will just work seamlessly. But there's protocols that it's so rigid. In fact, Ethereum is also like you need to
Right,
wait.
yeah, absolutely.
You can't do
No,
anything. You
absolutely.
just need to
Yeah,
wait
it's on the protocol side. It's
unless you
not on
want to take it off
Axelar's
chain.
side. That's 100% not your fault.
Yeah,
So
so
I'll
you
tell
just have to
Linea.
yeah, like you just have to wait
Yeah,
if you truly want it to happen on chain, unless you want something to happen off chain, which at the end of the day you realize that, oh, now this is defeating the goal of
right.
trustless,
Yeah,
transparent, and all of those
yeah.
things. Yeah.
Okay, cool. Makes sense. Wow, thank you so much. I learned so much today. This is really awesome. Are you gonna be in New York for ETH Global? Or like is Axelar
Um,
sponsoring? Do you know?
I don't know, but I think someone from the team should be there. Maybe not me.
Okay,
Yeah.
cool. Very awesome. So I'm excited to see what you
Yeah.
build. I know I've talking to a few Linea teams that are using Axelar or Linea dApps on Linea that are using Axelar. So very appreciative you guys are deployed so that other dApps can be enabled to build. Um,
Yeah.
but yeah,
Sure.
if you have nothing else to add, or if you have anything else you want to say, speak now, or I'm gonna end the stream.
Oh, okay. Yeah, so it feels good, right? And also debugging live to see what happened
Yeah,
when
yeah.
things fail. This is what we really try to go through, like during presentation or demo or trying to make things work. Yeah, so I encourage everyone to check out what Linea is doing and also how you can build and deploy on Linea. And then at the same time, check out what we're doing at Axelar to make it easy for you to facilitate cross-chain communications. And of course, you want to extend the capability of your decentralized application to like all ecosystem. Don't restrict yourself to one ecosystem. So with the Axelar SDK, you could just tap in, connect it with a single click. You can be able to you can facilitate this transaction between the chains seamlessly. And don't forget, on our Discord, we have the developer forum. We are always there to help you. And we also provide, like on the Axelar examples, we provide tons of examples for you to start with because we understand what it means to get started building. So we provide all these examples for you to just quickly start and then try to play around with things even before you start building the real world solutions. Play around with things, see how Axelar works, see how we're doing our cross-chain interaction, and understand why the need of a completely decentralized system for you to be able to do this cross-chain interaction.
Okay, cool.
Yeah, so thank you
Thank
guys.
you. Okay, I'm gonna end the stream. Three, two,